I'm Caitlin, and I'm going to show you how to solve your equation for your hyperbola. Find the different components so you can graph it. Let's start out talking with the type of equation this is. Since the y is over the a and the x is over the b, this is a vertical hyperbola. They're written in this form. And lie on the graph like this. In contrast, a vertical hyperbola is written like this. And lies on your graph like this. The center point, which is the first thing we're going to solve for, will be right in the middle of your two curves. Let's solve for your center point. Your center point will be found by using the two coordinates within the y and the x. Your first coordinate will obviously be your x. Take the inverse, -2, and the inverse, which is 1. This will be your center point of your hyperbola. Next, we're going to find the two vertices of your hyperbola. The two vertices are the two points at which the hyperbola is the closest. This is also called your transverse axis and has a general length of 2a. Now let's find your vertices. To find your vertices, all you do is take the square root of a, the square root of a squared, which is 4, and you subtract your 4, or add it, from your y-coordinate from your center point. Now the original coordinate is 2, 1. Let's start by adding it. This will be one vertice. Let's find your second vertice. Take your original point and subtract 4. This will be your second vertice. Next, I'm going to show you how to find the foci for your hyperbola. To find the foci, all you have to do is to use the Pythagorean theorem. The Pythagorean theorem. Since we have a squared and b squared already, all we need to do is plug in the numbers. Since there is no perfect root for the square root of 41, we're going to leave it as a complex root. Now, since there is a complex root, you know that there are two. They always come in pairs. So one is going to be positive and one is going to be negative. These are going to be your foci. Now to solve for your foci, take your original center point and subtract and add them from your y. It's going to look something like this. These are going to be your foci. Now that you have all of the components for your hyperbola, you can graph your equation. Let's see another example. As you can see, this is a horizontal hyperbola. Now, it's clear to me that the center point is 0, 0, because there are no numbers that go along with the x and the y. Let's write your center point up in the corner to keep track of it so we can find the vertices. Since this is a horizontal hyperbola, you want to subtract a from the x-coordinate. Take your center point one more time. Find the square root of a squared, which is 4. You're going to add and subtract it from the x-coordinate. Your two new vertices will be -4 and 0 and 4 and 0. Let's write your vertices up in the corner so we can keep track of them. Last, let's find the foci. Again, we find the foci by using the Pythagorean theorem. A squared plus b squared equals c squared. Since we have both a and b squared, all we need to do is add. And find the square root. Just like before, we have a complex root. Now you know if we have a complex root, there are always two. They're always come in pairs. So one is going to be positive and one is going to be negative. Again, since this is a horizontal hyperbola, we're going to subtract and add the complex root from the x-coordinate of your center point. Take your center point one last time, and you're going to add the square root of 41 to your x-coordinate and subtract the square root of 41 from your x-coordinate. These are your foci. Now that you have all the components of your hyperbola, you can graph. Let's see one more example to make sure you have a good grasp. Now again, this is a horizontal asymptote. A horizontal hyperbola. You're going first to take the center point from your equation. The x-coordinate will be 0, and the y-coordinate will be 0. You know that this hyperbola is centered around the origin. Now take your center point one more time so we can find the vertices. Let's take the square root of a squared, which is 6. Now since it's under the x, we're going to subtract and add from the x-coordinate. Your new vertices will be -6 when we subtract x, and +6 when we add x. These are going to be your vertices of your hyperbola. Finally, let's find the foci. Let's use the Pythagorean theorem one more time. And since we have the a squared and the b squared, all we need to do is add them and take the square root. Now 100 is a perfect square. So this is going to be a simple equation to work with. Now to solve for your foci, all you do is take your c, which is 10, and add and subtract from the original x-coordinate. Let's add 10 and subtract 10. These are going to be the foci of your equation. I hope this helps finding the components from your hyperbola equation. all of the basic elements, and I hope you are able to grasp it. Thank you for listening.